Imagine living on a floating city, thousands of people around you, aircraft taking off overhead, massive engines running below your feet and all around you. Nothing but ocean, no rivers, no lakes, no freshwater wells, yet every single day, the crew needs fresh water. They need it for drinking, for cooking, for cleaning, for showers, for medical facilities, and for countless other operations happening aboard the ship. But there is one enormous problem. The ocean surrounding the aircraft carrier is full of salt, so where does all that fresh water come from? An aircraft carrier cannot simply carry enough fresh water for an entire deployment. Water is incredibly heavy. 1,000 liters of water weighs roughly 1 metric ton. Now imagine supplying thousands of people for weeks or months. The amount of water required would become enormous. It would occupy valuable storage space. It would add weight to the ship. And once that water was used, it would be gone. So instead of depending entirely on water loaded before departure, modern aircraft carriers can make fresh water right there at sea. They take the ocean surrounding the ship and turn part of it into fresh water. The process sounds simple, but inside a modern aircraft carrier, it is a sophisticated engineering operation. Seawater has to be collected, filtered, desalinated, purified, stored, tested, and distributed, all while the ship continues operating thousands of kilometers from land. So how exactly does an aircraft carrier do it? Let's follow the journey. From a drop of seawater, a glass of fresh water, inside one of the largest and most complex machines ever built. An aircraft carrier may look like a massive floating airport. Its flight deck is enormous. Its hangars can hold dozens of aircraft. Its propulsion system can move tens of thousands of tons of steel through the ocean. But beneath the flight deck, there is something even more important: a complete support ecosystem, power generation, food storage, medical facilities, air conditioning, waste treatment, fuel systems, fire suppression, and water production. The ocean provides the raw material, the ship provides the technology, and together, they create a continuous supply of fresh water. This changes the way the carrier can operate. Instead of depending entirely on fresh water loaded before departure, the ship can produce additional water during its deployment. That doesn't mean the carrier can waste water. Quite the opposite. Water is still carefully managed, because producing fresh water requires equipment, it requires energy, and it requires maintenance. But the ocean provides something extremely valuable, an almost unlimited source of raw seawater. The challenge is removing the salt. At first glance, seawater looks perfectly clean. It is clear, it flows freely. And there is an enormous amount of it. But dissolved inside that water are salts and minerals. There are also suspended particles, microscopic organisms, and other impurities. Human bodies cannot simply drink seawater. The high concentration of salt creates a serious physiological problem, so the ship has to separate the water from the salt. And this is where the carrier's water production system begins, deep inside the ship. Special seawater systems provide raw ocean water to the treatment equipment. The process begins with an intake. Ocean water enters the ship through carefully designed systems. Pumps move the seawater through pipes. The water may first pass through strainers and filters, designed to remove larger particles and unwanted material. The goal at this stage is not yet to make drinking water. The goal is to prepare the seawater for the more demanding desalination process. Think of it as preparing the raw material before the real transformation begins, and this raw material is everywhere outside the ship. Millions of tons of seawater surround the carrier. Inside, a relatively small amount is continuously brought into the water production system. Raw seawater contains more than just salt. It can contain sand, marine organisms, suspended particles, sediment, and microscopic contaminants, so filtration is an important first defense. The seawater passes through specially designed filters and treatment stages. Larger particles are trapped, some contaminants are removed, and the water becomes suitable for the next stage. But there is still one major problem: the salt remains, and removing dissolved salt is much harder than removing visible particles. This is where desalination technology becomes essential. There are several ways to desalinate seawater. One major method uses heat, another uses pressure and specialized membranes. The exact equipment varies by ship and system, but the goal is always the same: separate water from dissolved salts. In thermal desalination, seawater is heated under controlled conditions. Part of the water becomes vapor. The dissolved salts do not travel with the vapor in the same way. They remain behind in the concentrated seawater. The vapor can then be collected, cooled, and condensed back into liquid water, freshwater. The basic principle is similar to what happens naturally in the water cycle. The ocean evaporates, water vapor rises, it cools, clouds form, and eventually, freshwater returns to the surface as precipitation. The aircraft carrier is essentially reproducing part of that process inside a machine, but it has to do it efficiently because heating seawater requires energy, and energy aboard a ship is valuable. Modern desalination can also use reverse osmosis. Instead of primarily relying on heat, the system uses pressure. Seawater is forced against specialized membranes. These membranes contain extremely small passages water can pass through, while many dissolved salts and contaminants are rejected. The result is two streams. One contains purified water, the other contains concentrated seawater carrying the rejected salts. The purified water continues forward. The concentrated brine is handled separately. Reverse osmosis can be highly effective, but it also requires powerful pumps, and those pumps require energy, so engineers constantly balance performance, energy consumption, equipment size, water demand, and maintenance. This is the most important moment in the entire process. A stream of seawater has entered the ship, salt has been separated, impurities have been removed, and now clear freshwater begins flowing out of the desalination system. But the water production process isn't finished. The water still has to be monitored because freshwater aboard a military ship has to meet strict quality requirements. The system can monitor things such as salinity and other water quality parameters. If something is wrong, the water can be redirected or the system can be adjusted, because this isn't simply industrial water. It will eventually support human life. Once freshwater has been produced, it enters storage systems. Aircraft carriers contain large tanks and extensive piping networks. The tanks act as a buffer. Water can be produced continuously, while demand changes throughout the day. During some periods, the crew may consume more. During others, the demand may be lower. Storage gives the ship flexibility. Pumps then move freshwater through the vessel. The water can travel to living spaces, galleys, medical areas, maintenance spaces, and other systems that require fresh water. What looks like a simple faucet may be connected to a massive network of pumps, tanks, valves, and pipes. Now think about the scale. An aircraft carrier can have thousands of people aboard. Every person needs water: drinking, cooking, hygiene, cleaning, medical care, and other daily activities. But the ship also has specialized requirements. Food preparation needs water. Laundry systems may use water. Maintenance activities can require fresh water. Medical facilities need reliable supplies. And the ship must maintain reserves in case something goes wrong. So freshwater production is not just a convenience. It is part of the ship's ability to sustain its crew. Without reliable water, the carrier's ability to remain at sea would eventually be limited. One of the most obvious places where freshwater ends up is the galley. Thousands of meals may be prepared aboard a large carrier during a deployment. Water is used for cooking, food preparation, cleaning, and sanitation. A simple pot of water in a ship's kitchen may have started its journey as seawater outside the hull. That seawater entered the ship, passed through filters, went through desalination, became freshwater, entered a storage tank, traveled through pipes, and finally reached the galley. That entire journey can happen without the crew ever seeing where the water originally came from. Eventually, the freshwater reaches the people aboard the ship. A sailor fills a bottle, a cook prepares food. A medical worker uses water in a treatment area. Someone takes a shower, someone washes their hands. For the crew, it can feel completely ordinary, but behind that ordinary glass of water is an enormous engineering system. The ocean is outside. The desalination plant is somewhere inside the ship. and between them is a network of machinery working continuously. But what happens after the water is used? The ship has to deal with wastewater, water from sinks, showers, kitchens, and other onboard activities. Wastewater can contain contaminants that cannot simply be released untreated, so different waste streams are collected and processed according to their characteristics. And the ship's environmental systems, some water may be treated, some materials are separated, some waste streams require specialized handling. The important principle is simple. The ship manages water from the moment it enters until it becomes waste. There is a deeper connection here. Freshwater doesn't appear for free. The ocean provides the raw material, but the ship must provide the energy. Pumps need electricity, membrane systems need pressure, thermal systems need heat, control systems need power, and all of these systems have to operate alongside everything else aboard the carrier: navigation, radar, communications, lighting, air conditioning, aircraft support equipment, propulsion, and countless other systems. This is why water production is an engineering problem, not simply a plumbing problem. The ship must produce enough water without consuming unnecessary energy. For nuclear-powered aircraft carriers, the energy situation is especially interesting. A nuclear reactor can generate enormous amounts of energy for long periods. That energy supports the ship's electrical systems and its propulsion system. It can also support energy-intensive equipment throughout the vessel. This doesn't mean the ship has unlimited resources. It still has finite food, finite spare parts, finite maintenance capacity, and thousands of people with physical needs. But nuclear power provides a major advantage. The ship can remain at sea for extremely long periods without needing to refuel its propulsion system in the same way a conventionally powered ship would. And that makes reliable onboard water production even more valuable. The desalination system is only one piece of a much larger machine. Water production depends on pumps. Pumps depend on electricity. Electrical systems depend on power generation. Water storage depends on tanks and valves. Distribution depends on piping. And the crew depends on all of it. This is what makes large naval vessels so fascinating. They aren't simply ships. They are floating industrial cities. They produce power, they produce freshwater, they process waste, they control temperature, they maintain breathable environments, they store food, they repair machinery. And they support thousands of people, far from land. Now imagine following one tiny drop of seawater. It begins outside the carrier, surrounded by millions of other drops. A pump draws it toward the ship. It enters an intake. A filter removes unwanted particles. The water reaches the desalination system, salt is separated, the water becomes fresh water, it enters a storage tank, a pump moves it through the ship. Eventually, it reaches a faucet, a sailor fills a glass, and that tiny drop has traveled from the ocean into the heart of a floating city and become something essential to human life. The ocean gives the aircraft carrier an enormous advantage. There is almost always seawater around it. But the same ocean also creates the problem. The water is salty. The ship must constantly protect its machinery from corrosion. Pumps and pipes must operate reliably. Membranes and filters require maintenance. And desalination equipment has to keep working, even while the ship is moving through changing ocean conditions. So the ocean is both the source and the challenge. An aircraft carrier can spend long periods far from shore. It may operate thousands of kilometers from the nearest port. That means resupply cannot always happen whenever the crew wants it. Food can be stored, fuel can be planned, spare parts can be carried, but water is consumed every single day. Onboard production dramatically changes the equation. Instead of carrying every drop from the beginning, the carrier can continuously turn seawater into freshwater. That allows the ship to transform one of its greatest surrounding obstacles into one of its greatest resources. Look at an aircraft carrier from above, and it looks like a giant floating runway. But beneath that runway is an extraordinary world. Thousands of people, hundreds of rooms, massive engines, power generation, aircraft maintenance, food preparation, medical facilities, water treatment, waste management, and life support systems. The ship is effectively a small city moving across the ocean. And just like any city, It needs water. The difference is, this city carries its own water factory. The journey began with seawater, saltwater, water that humans cannot safely drink. But through engineering, the ship changes it. Filters remove unwanted material. Desalination separates salt. Purification improves quality. Storage systems hold the finished water. Pumps distribute it, and the crew uses it. Every day, the ocean outside may look unchanged, but inside the ship, part of that ocean has been transformed. The impressive part isn't simply that an aircraft carrier can make fresh water. The impressive part is that it can do it while doing everything else. Aircraft are launching, engines are operating, radar is scanning the horizon, thousands of sailors are working, meals are being prepared, equipment is being maintained, and somewhere deep inside the ship, seawater is quietly being turned into freshwater. No dramatic moment, no visible spectacle, just pumps, filters, membranes or evaporators, tanks, pipes, and engineers making sure everything works. So the next time you see an aircraft carrier crossing the ocean, look beyond the enormous flight deck, look beyond the aircraft, look beyond the weapons and radar, because hidden inside that massive steel vessel is something much more fundamental, a system that takes the ocean itself and turns it into water that people can drink. A sailor may fill a glass with fresh water without ever thinking about its journey, but that water may have started as a tiny part of the ocean outside the hull. It was pumped aboard, filtered, desalinated, purified, stored, transporting through the ship, and finally delivered to a human being. That is the hidden infrastructure of life at sea. An aircraft carrier isn't just a floating airport, it is a floating city with its own power plant, its own water factory, its own waste systems, and its own carefully controlled environment. And perhaps the most remarkable part is that all of this happens while thousands of tons of steel move across one of the largest and most unforgiving environments on Earth. The ocean provides the water, engineering removes the salt, and the ship turns that water into something every crew member needs: fresh water. Because when you are thousands of kilometers from land, the difference between seawater and drinking water isn't just a matter of taste. It is the difference between surviving at sea and having to return to shore, and that is how an aircraft carrier makes fresh water in the middle of the ocean. If you enjoyed this documentary, subscribe to the channel for more fascinating stories about technology, engineering, science, and the incredible machines that make modern life possible. And I'll see you in the next documentary.